So we'll start Boolean algebra now, and in Boolean algebra, today's lecture we'll talk about what is Boolean algebra. We'll introduce the algebra, and we'll also talk about how to write and work with Boolean expressions. So Boolean algebra is basically algebra of zeros and ones, and these are called Boolean variables, variables that can take only two values, 0 or 1. And again, this is important for especially computer science, because computers understand language of zeros and ones, and so there's a whole algebra that is based on this. And Boolean expressions are basically combinations of Boolean variables, right? Like x, y, z. We know that mathematical expressions, the same way Boolean variables can be combined together to build Boolean expressions. So we have seen truth tables, right, in the chapters where we discussed logic, right? So this is exactly the same idea. So what we're going to do is we're going to replace false with 0, and this is an analogy I gave in that chapter also, and because it's more intuitive, true is 1 and false is 0. So you can see that there's a one-to-one correspondence between the tables. 0 multiplied by 0 is 0, 0 times 1 is 0. So this is the AND operator. Remember we saw that. Now instead of the symbol, we're just going to use the dot to represent multiplication or the AND operation. And so remember, it's only true when both of the input expressions are true. And so when both of the values, Boolean values are 1, you get 1, otherwise it's 0. And so similarly, the OR operator, as I said in that chapter also, the OR operator is more like addition. 0 plus 0 is 0, and 0 plus 1 is 1. So all of these, remember, give true values, except when both of these, the input expressions are 0. You get 0 or false, otherwise it's 1. And similarly, the NOT operator is the same idea. The NOT of 0 is 1, and the NOT of 1 is 0. Now let's look at some Boolean expressions. So again, as I said, Boolean expressions are combinations of Boolean variables. Now over here, x and y are Boolean variables. They can be 0 or 1, right? So we're just assuming that let's assume that all of these are equal to 1. So the way you evaluate is that you replace x with 1, y with 1. So 1 times 1 is 1. So this is the AND operation. Sometimes you don't see the dot over here. It's fine if you don't write the dot. You should know that it's if you don't see a dot in the expression, you should know that it's multiplication. But you can see over here, there is an explicit dot written over here. So this is also the AND operation. So z is 1, so this is z bar. The bar means that again the bar would mean the complement or the NOT operation. We also call it negation, remember. So z is 1, so 1 bar is 0, so you get a 0 for this. So you're left with, so this part gives you 1, so on this part you're left with 1 multiplied by 0, and so you get a 0. So this whole, so you have a 1 over here plus 0. So 1 plus 0 is equal to 1. So this whole expression x, y plus 1 times z bar is equal to 1 for this combination. Remember that we're assuming input values. So for these set of input values, the expression gives you a 1. Let's look at another example. So in this case, you have x plus z, and then 0 plus y. Bar is over the whole thing, and then that's in parentheses being multiplied by z. Now, in this case, the set of input values are x equals 0, y equals 1, and z equals 1. And so in this case, so when you have a bar like this over the whole expression, you have to first evaluate what is beneath that bar, and then you take the bar or the negation of that expression. So 0 plus y is 1, right? So first you have to figure this one out. So 0 plus 1 is 1, and 1 bar is 0. So you get a 0 so this part in the parentheses gives you a 0. And then you evaluate z. So z is 1 1 multiplied by 0 is 0, and then x is 0. So this whole expression gives you a 0. Now, so there are a set of laws. So remember we saw a table for the logic operations, also how to evaluate logic expressions. So this is the same, it's a very similar table. There is an idempotent law, associative law, and so on. And then when you're evaluating a Boolean expression, you have to use these laws in order to evaluate. So for example, look at this, like x plus 1 is always 1, right? So this is because of Boolean algebra, because no matter what x is, 0 plus 1 is 1, 1 plus 1 is 1. So x can be any value. So the x and the y's and the z's can be any values. So what this means is that it's just these expressions mean that these are going to be true in general. These are laws in Boolean algebra. And then when you're evaluating Boolean expressions, you have to use these laws. So remember this is the De Morgan's law, right? We have seen the De Morgan's law. So if you want to go back to logic, remember we did this, not of P and Q is equal to not of P or not of Q, right? So the and becomes an or, this is Q. So if you remember this law, right? So this is the same over here, and what I did over here is this one. Right? So it looks much more cleaner, right? So this is x multiplied by y. This is P and Q, and the negation of that, the negation is the bar over here, and that is equal to not of P, which is not of x over here, plus not of y, and you have a not of Q. So it's exactly the same thing, and similarly for other expressions. So let's look at an example. Now you'll get these type of questions. So this is I think this is a question in the worksheet also. So when you have such an expression, this is how you would prove. Now, the question says that you have to prove using Boolean algebra or the laws of Boolean algebra that this expression or this equation is true. And the way you start this question is that you start with the left hand side, and then you start using the laws that are from the Boolean algebra. You start using those laws step by step, and then you should end up with the right hand side. So again, so you start with left hand side. This is your left hand side, right? Equal to that, and so this is equal to that, this is equal to that, this is equal to that, and this is equal to that, and you eventually get the, and so this is your right hand side, right? So this is how you prove an expression, right? When you've been given an expression, you have to follow these steps. You start with the left hand side, and you should end up with the right hand side. I'm repeating this again because I know that students from my experience, if this is something students find difficulty with improving. So let's go step by step in this. Okay, so this is your left hand side, right? Left hand side. This is this side, right? So now we're going to use a distributive law. You don't really have to write these, right? Each step. This is fine. It's fine with me. And you don't have to memorize all these laws. I'm going to give you these laws if you need them. Try to focus on the concept. Don't worry about memorizing these things. So now what you're going to do is you're going to use the distributive law, right? And then multiply the x in. So this is simple multiplication also, which you intuitively know, right? So that's why I'm saying, this one is obvious. You don't even have to write that it's a distributive law, right? But now what do you do next? In Boolean, so this is obviously specific to Boolean algebra, that x multiplied by x is going to give you x, right? So now you replace x multiplied by x equals x, and so this is it's over here, right? The idempotent law. So now you use the idempotent law, right? And then you write this. Now you're going to again to use this distributive law, which is just factoring out x, right? So again, you don't really need this is true in general also, even with general mathematical expressions. So you take x, factor out the x, right? And then you're left with 1 plus y bar, or y bar plus 1. And so y bar plus 1 is always going to give you anything plus 1 is going to give you 1. Where is it? Yeah, over here, right? You can see, right? So this can be x bar also. X bar plus 1 is going to give you 1. So you're left with 1 in this part, and then x multiplied by 1 is obviously a 1. And so you get the right hand side. So this is your right hand side, and this is how you would prove any expression, a Boolean expression, when you've been given. So there are a few questions in the worksheet also. So make sure you go through these. Try to find the law that you should use in order to prove an expression. Start with the left-hand side, look at the table, and then try to find a law that can work, and then try to get to the right-hand side in order to prove that Boolean expression.